Hey guys, and welcome back to a new video. Thank you so much for all the great feedback about the recent Spring Boot crash course with Kotlin, in which I really taught you how you can build your own backend with the Spring Boot framework using Kotlin. And because the feedback was so awesome, let's extend this a little bit. And in this video, you will really learn how you can now take this existing backend and deploy it. If you haven't watched this crash course and you really just want to learn how you deploy a Spring Boot backend, then you can of course also fully follow along here. I will just take the backend that we've built in the crash course as an example here to deploy that. But if you have your own backend, then you can just follow along the same way. Because in that crash course, after all, you've learned how you can build a backend that does something. So here we've built a little node-based backend that is able to store certain nodes in a remote database, in a Mongo Atlas instance to be specific. And we can also authenticate, so we can register, log in, and we have a refresh token mechanism here. And having this backend, of course, is not really useful if we just use it locally. So we can connect to our local machine, of course, but if you really want to make use of that backend and let maybe a website or a mobile app connect to it, then you have to deploy it. You have to take this code and run it on a remote machine where other clients can then connect to. And this is exactly what I will walk you through in this video. Step by step, I will explain every single detail. So if you've never deployed a backend in your life before, then in this video, everything will be explained. Down below, you will also find jump marks. So in case you already have a certain base setup and you just want to follow along from a specific starting point, you can just advance there. Or if you say you have no idea at all what this is about, then just follow through this video from beginning to end. And what's maybe important to mention is that this is not constrained to Spring Boot backends written in Kotlin. So you can see we wrote this in Kotlin code, but very popular for Spring Boot is of course also Java, since that is what it was originally meant to develop for. If you have a Java-based Spring Boot backend, then the steps that you need to follow are exactly the same as for Kotlin. And in the end, even if you have something like a Ktor backend, just anything where you can generate a jar executable, the steps will be the same, except for maybe 1 or 2% where a command differs or so. But even if you're a Ktor backend, you can also follow through this video, just like for Spring Boot. And this video will really consist of two parts. Part number one is just creating a server, so a remote machine where we can really deploy our backend to, setting that up, securing it properly, and then first of all, manually pushing our Spring Boot code, our executable, to that remote machine so we can run it, we can already test it. But in the second part of the video, I will then also show you how we can automate that part, because manual pushing to these remote machines is quite tedious. So in the real world, how these things typically work is, for example, via a GitHub Actions pipeline. So that what we will actually achieve here is, whenever we take our project, our Spring Boot code here, and we make another push to the master branch on GitHub, then this new code that we push there will automatically be deployed and made live. This is what then comes in the second part of the video. But first of all, in the bigger part, you can see I am here on Hetzner. That is a very popular cloud host, a German one, but also very popular internationally. This is what I will use here for this video in order to deploy our backend to. So we will create a VPS instance, a virtual private server. That is pretty much the cheapest option available to really host code like that. And this is not always the best option if you really want to have a big user base and your backend really has to have really good resources in regards to CPU, RAM, and so on. But if you really just want to learn backend development, you want to learn deploying something there, and you want to just play around, then VPS instances are super cheap, like $3 or $4 a month, and you can deploy as many backends to it as you want, at least for testing. Of course, deploying your backend code to such a VPS instance isn't the only option. There are also other options, very popular, for example, these typical cloud providers like AWS, Google Cloud, Azure. These cloud providers do have the advantage that on the one hand, scaling is typically easier. So if your user base suddenly grows super quickly, then it's much easier to actually add more machines, spread your backend code over multiple machines, add some load balancing to decide where the traffic goes. So there's more complex stuff, which is also possible with Hetzner. So here with Hetzner, a VPS instance is really just our own shared space of a remote machine. So you must imagine that there is some kind of remote machine running on Linux in this case. And this remote server, this hardware machine, is then separated into multiple virtual units, which makes off such a VPS instance, which is why it's called virtual private server. There are also so-called dedicated servers. So that means you rent a server and the entire physical machine is yours. So you don't share these service capacities and these server resources with other servers, which makes a whole lot of sense if you have a backend that really requires lots of CPU and RAM resources. But in our case, as I said, the cheapest option is really just renting such a VPS instance here for $3 to $4 a month. And I also want to say that using Hetzner is not mandatory here. I'm not sponsored by them. I just use them personally for my own backends as well. And I really like them, which is why we will follow along here. I will also put a link down below where you can register there. This is an affiliate link, so I get some credits here if you get a server there. So if you want to support this channel, then thank you for that. But you can also perfectly follow along if you just go to another hoster, create a VPS instance there. What matters after all is that you have some sort of remote access to a Linux instance. And this is, by the way, also a trend that I currently see, that people start to go back from all these cloud hosters like AWS to self-hosting on Hetzner, to at least have a hybrid approach. That is also what we use here. So we have our own instance deployed on our own server here that we fully control, where we can fully send any type of shell command to, but then at least have certain parts of our backend still run in the cloud. Specifically, I'm thinking of the remote database here. So we still make use of Mongo Atlas, which is running on another remote machine technically. So this is the database instance is not going to be hosted on our backend server that we host here. It's on a remote machine here in Mongo Atlas. And also if you have things like, for example, you need to upload images and store these, then I would probably also not store these on the actual Hetzner instance, but rather something like S3, so from AWS. So I would rather cherry pick those services that you need that make certain things easier. Especially for storage, these cloud providers can make your life a whole lot easier when it comes to things like backing up your data, scaling that, and so on. And this is also not usually the expensive part about the cloud hosting. But when I personally moved my own deployed backends away from AWS, so where we really had the deployed server instance on AWS, to my own Hetzner instance, I've really reduced the monthly cost by a factor of 10. So it's crazy how much money you save there. All right, but I would say we can get started. In this video, we will make a lot of use of our terminal, of our command line, if you are currently watching this on a Windows machine. So I'm here on macOS, and if you're on Linux, then you should just be able to type exactly the same stuff that I'm able to type here. But if you're running this on, if you're watching this on Windows, then please make use of this git bash. So this is kind of a shell that is much more similar to the Linux and macOS terminal, because the typical Windows PowerShell just does not have certain commands we need to make use of here. Okay, but step number one, if you want to follow along, is go to Hetzner or your hoster of choice, register an account there, log into that account, and then it will look something like this. If this does not look like this, then you need to take a look here at these little this menu kind of icon, and then you need to click on Cloud. So since I am already here on the Hetzner Cloud, this doesn't appear here, but in this options, if you're not on this website, on this specific cloud console here, then Cloud will appear. You click on that, and then it will look similar to like it does here. This is now the web dashboard where we can create and configure our remote server, our Linux machine. So for you, if you're new here on Hetzner, then you wouldn't have these projects. You would just click on a new project in order to just create a new project where you can then just host certain servers in. So we can just, I'll just create a test one here because I already have the YouTube one where I have a hosted Hetzner server, a Hetzner instance. We click Add Project. There we are. Our project is going to be created. Takes a little moment. And then in here, you will be able to actually create such a resource. And now in the following, I will lead you through two scenarios that could apply in your case. Scenario number one, you don't yet have your own instance of a VPS server, and you just want to follow along, create this, and learn how you can set this up here, specifically on Hetzner. Scenario number two is you already have your own rented VPS instance that you are able to connect to via SSH. If that applies, then you're free to skip this section until I show you how you can set up that VPS server. So then you don't need to follow along and actually create that server here on Hetzner, but rather just connect to your existing server. And scenario number three, if for some reason you decide to not host your backend on a Hetzner server, but on some kind of other hoster, then in order to follow along after that, you need to be able to connect to that server via SSH. The setup steps are always very similar from hoster to hoster, but obviously I can't show you all hosters out there, so we need to pick an example, which is going to be Hetzner in this case. So starting with creating a completely new resource, a completely new instance of our server, a completely new remote machine that we can then later on connect to. On Hetzner, that works by creating a resource here via this big prominent red button. We want to create a server, and then we are here on this separate page where we can configure this. So on the one hand, we need to pick a location where this server is located. Obviously, here choosing something that is as close to your users as possible makes sense, because the less distance data needs to travel, the faster the communication with that backend will also be. So in my case, I will choose Nuremberg. For the actual OS that should be installed on this server, we will choose Ubuntu version 24. So you can leave this at the default. Then for the type, importantly, we need to select whether I want to have a shared CPU or a dedicated CPU. So this is now exactly the distinction that I shared with you before. Shared CPU means there is one physical server instance which is separated into multiple virtual environments where you get your own part or your own virtual environment that in the end runs its own isolated OS, but the actual physical CPU resources are shared with other servers, well, with other virtual environments at least. While if you choose dedicated CPU, then you will really get your own CPU that entirely works for your own server and backend code. This is obviously also quite more expensive. In my experience, around 10 times the price of such a shared CPU, depending, of course, what kind of CPU you go for. It's still very affordable. So for this one, you pay like $50 a month or so. So if you're serious about your backend and you really want the full performance, then I will always go for this pick, especially if you run a business around your server. This is still way, way, way cheaper than cloud providers like AWS. But for this tutorial, we're completely fine with a shared CPU. So this is this VPS that we'll create here. We click that. Intel is fine, or Intel and AMD will now be shown. And here we can then see which specific configurations here we can choose from and which price each of these configurations would result in. As I said, if you just want to have a kind of a playground for yourself in order to deploy backends, experiment with how Linux works, how you can configure that, then you can really just go with the cheapest option here, which is this one, for €3.29 a month, so super affordable. This is probably the biggest return of invest that you can get for your money if you are serious about backend development and you want to practice deployment. Obviously, if you have a real user base and your backend needs to handle a lot of requests at the same time, then you need to consider if you need more CPU resources, more storage, more traffic, and so on. We will go with this cheap option here, so we can scroll down. Networking we can leave unchanged. And then we get to this SSH key section. This is an important one. This is also what you will likely get when creating such a server here on another hoster. So on one hand, SSH is the protocol that we will use in order to connect to our Linux machine. Because in the end, this is really just a Linux OS running on some kind of machine somewhere else. This is not our typical machine that you're currently working on, where you have your monitor and you can see everything. So there still needs to be a way for us to connect to that remote server and execute commands on it, to configure it, to create files, to upload our personal backend executable to that server in order to run it on that remote machine. And connecting to that server and being able to send shell commands to it, that works via SSH. And obviously, if we want to be able to connect to such a remote server, there needs to be a way for us to authenticate. That works typically with SSH via a password. So you say, I want to connect to this server with this user, here's my password, and then you have access. Or alternatively, via these so-called SSH keys, which is a very popular option. So an SSH key is in the end just a set of a public and a private key. So really just a file with some cryptographic stuff in it, where the public key is then going to be pushed to your server. So that's public. That is not a problem if people see that. But with the private key, which you should keep private on your machine, you will then be able to log into that remote server via SSH just by specifying that key file without needing to enter a password. This will become especially important later on when we work with GitHub Actions in order to automate the deployment via our pipeline. And here you can just choose that initial SSH key you can create in order to also initially connect to that server. And that's important to know and to also do here. If we click Add SSH key, we need to directly paste this key. How do we get this key? We need to create this on our own here on our local machine. How does this work? You need to open up your terminal. So on macOS or Linux, you know what the terminal is. You can just open the terminal right away. If you're on Windows, make sure to use the git bash as I mentioned. I have the terminal open here. And this is by default here in our default users folder. So if I type pwd to print the current folder, you can see I'm really just in my users folder. Inside of this users folder, there is a .ssh folder. So we could cd into that. Cd is a shell command to change the current working directory. And we could say cd.ssh. I'm not entirely sure if on Windows this .ssh folder is also in the users folder. I think so, but if not, if you run into any issues and this does not exist for some reason, then you need to look where this .ssh folder is, but there certainly is also such a folder on Windows. Because this .ssh folder is the folder where the SSH command that we will later use to connect to our server, that the command will use to look for when specifying such a key that we want to use in order to connect to our backend. So here, if we type ls in order to list all files, you can see a lot of these files. For example, here I already have a Hetzner key that is able, that helps me to connect to my other Hetzner instance. And every single SSH key consists of this private key without an extension and a public key that has the .pub extension. And this public key, this is now the type of key that we need to generate client-side here on our machine, then copy here into our SSH key text field, which will then be used to set up our server with. So we can then connect to the server directly just by using this private key that was generated together with this public key. So let's do this via the SSH keygen command. We need to specify the algorithm we want to use for this, so the cryptographic algorithm, which is called ED25519. That's just the most secure algorithm for these key files at the moment. We need to specify the size of our key, which will be 4096 bytes. And optionally, we can specify a comment, so who this key may be owned to, for example. For example, Philipp. If we then hit enter, we are prompted with a question to enter a file name for this key. And here I will simply choose notes, because the Spring Boot backend here is for saving some notes, but of course choose something that helps you to later on recognize which key is used for what. If we now hit enter, we are prompted with a passphrase, because additionally, we can also secure this private key with a passphrase, which we would need to enter in order to authenticate with this private key. I am not going to choose any passphrase here. You will later understand why. So you can also leave this empty, because the key file itself is kind of already the password. So just hit enter, enter again. And if it looks like this for you, then everything was successful. Now, here in this .ssh folder, we can actually print this key, this public one, not the private one. And the private one should really stay on your machine. You should not share it, because it's really like a password. Anyone who has that key is later on able to connect to your server and run commands on it. But we can print the public key with cat and then followed by the file name, which is notes.pub. If we hit enter, then this is how this public key variant of this key actually looks like. We simply copy this, paste it in here in Hetzner, and you can see the name is also automatically inferred. You can select this, set this as a default key, for example, click add SSH key, and then that is going to be used for this new instance that you create here. It's important to mention that if you already have an existing Hetzner instance, that adding a key won't automatically add it to your existing instances, but these will really only work for instances that you create as new instances. All right, let's scroll down. You could optionally add some more volumes if you need more storage. We don't need this, we already have SSD storage. Firewalls you could set up, backups. So if you have certain data or configuration you need to regularly back up, then you can let Hetzner do this for you. So if you want this, tick this, I won't. Placement groups we can skip, labels we can skip, cloud config as well. And you can optionally also choose a different name other than this one, and then simply click create and buy now. Obviously, you are probably going to be prompted with your payment details, but you can see this specific instance would be €3.79, which is super affordable. After you've created that instance, it will look like similar to my YouTube project for you, which is already an existing instance that I have, since I won't create a new one here. Under servers, then you will see a list entry like this. Because the moment you create a server, you will also get a public IP address. This is important. This is just like your URL that we can then use to connect to the server. And if we click on it, here we can really configure everything just like we want. In case you already have an existing instance, an existing VPS server, what you need to do in order to follow along is you need to also copy over this SSH key we just created. In case you skipped that section, please take a little look back where I create the SSH key with the SSH keygen command. But you now also need to take this key and copy it over to your existing VPS instance. So if you've really just created this resource here as a new server, then you can ignore this part, since the SSH key we've specified is already on the server, since we've mentioned it during setup. But if you have an existing instance and you don't yet have an SSH key for it, then you also need to go in your terminal where you have this public key variant of this SSH key, and you need to copy it over to your just created server instance. This works with the ssh.copyid command in order to copy an identity file. We specify the identity file with -i. And here in this case, I am already in this .ssh folder, so we can directly reference the key. If not, you need to specify the full path. So the key name here is simply notes.public-key, so .pub. And lastly, we need to specify the server address that we now want to copy this key to. Specifically, whenever you create a VPS server or dedicated server, you will be able to only connect to that server via the root user, so a user who has full privileges to that server. So we need to specify this root user, followed with an @ which now, where we now have to paste the IP address of the server. So we can click on this, whatever you've created, copy this, paste it in here, hit enter. Then the first time you try to connect to such a new server via SSH, you're prompted with this. So, hey, I don't know this server yet. Do you want to add it to the known ones? Yes, we do. So we type yes, hit enter, and then we're prompted with the root password. Because now in order to really copy a file, so this public key, to our remote server, the command obviously needs to know the server's root password in order to really have access to it. Here on Hetzner, you can find out the root password by going to rescue and actually resetting the root password in this case. But if you're using a different VPS provider, then you will know your root password. So if we hit reset root password, reset, you can just see this here. I will reset it anyways again. Copy this, go to the terminal, paste this in here, hit enter, and then you can see if it was successful. It says number of keys added 1, so the key is now actually known by our backend. Maybe worth to mention, if you have an existing instance running on Hetzner and you actually just reinstall a completely blank new OS via this rebuild here, you could use this to just install the OS again on the server, erasing all your data that way. Initially, the root login with a password will be disabled from Hetzner, so you won't be able to log in via SSH by specifying your root password, even by specifying the one here under with the rescue command, rescue tab. In that case, what you would need to do is you would need to open this web console of Hetzner, log in there with the root and your password. That will work. You need to then change your SSH config. There is a config file, and explicitly enable that root login with a password. This is kind of an edge case. It has happened to me before. It's likely something that doesn't apply to you if you're watching this. Just something that I think is worth mentioning. So you need to first enable root login via password, and then you can copy over your SSH key here. Or alternatively, you create this SSH key file directly here in your Hetzner root console, and then you will be able to log in your account with this SSH key. We can now test this. So regardless of whether you've created this as a completely new server instance or you already have an existing instance where you've now added your SSH key, the public key here, via the SSH copy ID command. In either of these ways, we now come to the same next step again, and that is attempting to connect to our server via SSH here. So we type SSH. We want to use an identity file, so -i, and this identity file is called notes. So here we now need to use our private key in order to authenticate to our server. We specify our IP address, copy over that, and if everything was successful, then we should now be able to log in with this command without having to enter a password, because we specified this SSH key file. So let's hit enter, and that works. Yes. So if you see something like this, then everything was successful. All the commands we now type here in this terminal from now on will be executed on our remote Ubuntu instance running as the root user. So now technically, we would be able to just generate an executable jar file of our backend, so just an executable Java file, push this to this server, execute this here, and then connect to this via our IP address. But we don't yet want to directly skip to that step, because there is still some work for us to do in order to do it right. On the one hand, we need to properly secure the server. So what's usually not a very good idea is to leave this as the root user and always work on your server as the root user. This is the only user account we have right now, but you must always imagine that if you are logged in as a root user, you have the full privileges over the entire server, and for no command, you need to explicitly specify that you want to run it with root privileges. So that means if we would now run our backend as a root user, and we would maybe have some other programs running here, and there would be a malicious one that would try to escalate the privileges to just be able to execute certain commands as the user this other program was launched with. If that is launched as root, then escalating privileges would mean full access to the entire system. And obviously, we want to restrict that as much as possible. So on the one hand, what we want to do is we want to create another user here on this Linux machine. We do give this user the option to, of course, run commands as an admin, because that's definitely something we do need to do here and there. But we also say that doing so only works via sudo. So sudo is, if you're a Linux user, you will know this, but it's a command that lets us execute a shell command with admin privileges. But using sudo will always also prompt us with a password. So this works like this. We can use the add user command in order to add an admin user, for example. Feel free to call this as you like. Then we are prompted with a password that we want to choose for this user. This will also be the password you can then later on connect with via SSH. So I will choose a password here, need to retype this. Then we need to specify the full name. So we just enter this one here. For the rest, we can really just skip this. You can just hit enter here. You don't need to specify all these details. Hit enter, we type Y so that the information is correct. And then we've successfully created that admin user. Now, next, we need to type user mod in order to modify the privileges of that user. Specifically, we want to say -a capital G sudo admin. So this command, we're still running this as root, where we have full privileges. This command will now give the admin user the option to execute commands with sudo, so with admin privileges, if they use this command before the actual command they are about to execute. So if we hit enter here, then if on Linux you don't see anything, then that typically means that was successful. So now we've set up that admin user. We have configured it, so the admin user has to run admin commands with the sudo command here as well. What remains is that we also want to be able to log into this remote machine with our admin user via the SSH command and our SSH key file that we've previously generated. So right now we would be able to log in by just not saying SSH root, our IP address, but saying SSH admin at our IP address. This would then prompt us with the password from that we've just chosen here for the admin user. And if we enter that, we could log in with this admin user already. However, logging in with our SSH key file that we've previously generated does not yet work, because that by default is set up on a per user basis. That means right now only the root user would be able to use that. And we can also check this if we type pwd to again get the current working directory where we are currently in the root folder. So this is the kind of personal folder of the root user. And if we type ls-A here in order to list all files, including the hidden files, then we also see this .ssh folder here that has been created via the SSH copy ID command, or initially when we specified those SSH keys from our Hetzner console. If we open this, so if we navigate into this SSH folder and we type ls again, then we see this authorized keys file. This is really a file that includes the information about the public keys that can be used in order to authenticate here to the server with their corresponding private key. What we now effectively need to do in order to allow our admin user to also connect with the same private key that we've previously specified, what we need to do for that is we need to take this authorized keys file and create a copy of it that we place in the personal working directory of the admin user. Specifically, that is /home/admin. So here, this is now the personal directory that was also generated when we created that user. And here in this directory, we now also need to create such an SSH folder together with the same authorized keys file. So that works by saying mkdir, so make directory, and to create a new folder, .ssh. Then, since we've created this SSH folder here as the root user is also automatically the owner of that. However, what we want is that the admin user is the owner of this SSH folder, so they can freely operate on it without needing any extra privileges. And changing this works with the chown command, so change owner. We say -r, and we change the owner to admin. So the first is the actual user, and a user on Linux can belong to a certain group, which we specify here with the second option. And I'm pretty sure we need to specify the .ssh folder, so we want to change the owner to the admin user for this SSH folder. If we hit enter, then that seems to be successful. We can then also change the specific permissions of that folder to 700 for the .ssh folder. So 700, this is a kind of cryptic Linux way of specifying file permissions or folder permissions. So the first digit of this 700 here really just corresponds to the permissions that we want to specify for the owner of something. So for the owner of this .ssh folder, which is now the admin user. And a 7 consists of 1 plus 2 plus 4. 4 means read access, 2 means write access, and 1 means execute access. And if we add all this together, then that means the owner, since we are talking about the first digit, the owner of this .ssh folder has full permissions over this folder. So reading, writing to it, and executing it. Hit enter here, then that was also successful. And the last thing we now need to do is we need to take this existing authorized keys file here from our root folder, this one here, and copy it over to this new SSH folder from the admin user. So we say cp for copy, want to copy the file from /root.ssh authorized keys. And this file we want to copy into our current working directory here. So /home/admin, and we say .ssh. If you're not in this current directory, make sure to type the full path. So home admin.ss. This should be it. If we hit enter, then that seemed to be successful. If we now cd into our admin SSH folder, type ls, then here we also see our authorized keys file now belonging to this admin. This is now the last thing we need to change the permission for. So right now we've changed the permission and the owner for this SSH folder to the admin user. Now we also need to do the same for the authorized keys file that we've just copied here. But here it's fine if we just say change mod to 600 this time, since this file doesn't need to be executed. Here we just say 4 plus 2, which is 6. So the 4 again corresponds to read permission, 2 corresponds to write permission. So the admin user would be able to read and write to this file. And we say we want to do this whole thing for the authorized keys file. Awesome. We can also confirm whether everything worked here with changing the owner, changing the permissions by typing ls-l. So we want to get more information for the files in this current .ssh folder. If we do this, then you see that actually that the file still belongs to root, which we should probably change. But let's first of all do this for the SSH folder for which we changed the owner. So ls-la to list all files, also hidden files with the owner. Here for this SSH directory, you can see the owner and the group are both admin. And the owner of this file has read, write, and execute permissions. That is how you need to read this. But let's still change this. I'm not sure if we need to change the owner of this authorized keys file, but let's better do this by saying change owner -r admin:admin, and the file we want to change is the authorized keys file. If we now type ls-l here, then you can see this file now belongs to the admin user, and the admin user, so the owner of this file, can read and write from this file. All right, so quite a lot of setup here in order to configure this admin user and letting it connect via an SSH key. The last thing that I now want to do is I want to disable root login. So right now we are logged in with root, but to be fully on the safe side with our server here, we want to prevent SSH login via root in the first place, so that we couldn't even accidentally mess something up with these root privileges. And that works by typing nano. So nano is the Linux command for the nano editor, so in order to change the contents of a text file. And we want to say nano etc/ssh/sshd_config. This is the configuration file for the SSH command, in which we can say, when connecting to this server here via SSH, then we don't want to allow root login. If we hit enter, then you can see here with the arrow keys, we can navigate. And right now, in my case, you can see this line, permit root login, yes. If you've created a fresh new Hetzner instance, then this is likely equal to just something commented out here with this hashtag, because I think initially Hetzner disallows root login via a password at least. Not with an SSH key you've previously set up, but via password. Still, I want to uncomment this and set this to no. So the root user wouldn't even be able to log in with an SSH key. So we save this with, for me, it's Alt and S. Hit Alt and X in order to get out of this editor again. And lastly, we need to type systemctl restart SSH. This will restart the SSH service, so the program that accepts these connections, just in order to really reload this changed configuration file here. Once we've did that, we should not be able to log in with the root user anymore. Let's test that. let's type exit here in order to exit the connection. Now try to log in with root first. So we again have the same command that we previously used in order to connect here, specifying the identity file that led to a successful connection. If we hit enter now, then you can see even though we specified our correct identities file, we are prompted with a password, but even if we enter the correct password here, it will say access denied. However, if we now say admin, and I hope this works now, if we type admin, so we want to connect as the admin user with the file, hit enter, we are logged in with the admin user. Awesome! So you can see that now works with the same identity file because we've previously copied this over here to the SSH folder of that admin user, changed the owner to the admin user and so on. So when we attempt to now connect to this server via SSH with the admin user, then the SSH program, the SSH command will take a look in this SSH folder of that admin user we are trying to connect with and checks if it has a corresponding public key that matches the private key we've tried to connect with. And that apparently worked very well here. Okay, perfect. One more thing that is optional at this point that I still want to show you, which adds a lot of convenience to connecting to this backend server here, is to set up an SSH alias. So you probably need to connect to the server quite often when you have a deployed instance there, and always having to type SSH-I, refer your private key file, then having your IP address, remember that. That's quite tedious, you forget that, you always need to copy paste stuff. We can set up an alias for this, so we can just say something like SSH notes, and then we'll automatically connect to the notes server instance here. In order to set this up, we need to open up the folder with our .ssh folder on our local machine, so macOS here. I will move this over here. I just opened it in Finder. That's a bit easier to edit things here. And specifically, we now need to take a look here in this config file, which is also being placed in this SSH folder. If that doesn't exist for you, feel free to create a new one. But if we open this, then you can see here's already an existing piece of config that lets me connect to my previous existing instance. If we now go to a new line, we can also specify another piece of config here. For example, let me call this YouTube. You are welcome to call this anything you like. We have 4 spaces here. We specify the host name of our server, which is the IP address. We copy over, to Finder, paste this in here. Then the user is also called admin here. The identity file, identity, is our private key that we should use for this connection. So use this .ssh/notes. That's the private key. And lastly, you want to say identities only. So we only want to be able to connect with this identities file. Hit save here. And if we then close this and also go back to our terminal, where we are currently logged in, but we exit this connection again, then we should now be able to log in with just typing SSH YouTube with the alias we've specified before. I'm not sure if we need to refresh the SSH command here client side, but let's try this, SSH YouTube. Yes, that worked. We are now logged in just by typing SSH YouTube. This is now much more convenient in order to connect to this remote server here. All right, I know this was quite some work in order to really secure this properly here, in order to disallow root login, but I really just want to show you the full picture. I don't just want to show you the bare minimum, and then you later run into security issues. No, I want to show you this once and for all, and then afterwards you will really understand every detail of this deployment process. So what comes next? Next up, we want to install certain programs here on our remote server, because we really just have a completely blank Ubuntu setup. In order to really execute our Spring Boot backend here, we will later on generate a jar file, so an executable Java file. But in order to run this jar file on our remote server, that remote server needs to have Java installed, obviously. So we go to our terminal again here, being connected now to our remote server, and we type sudo. So now we always need to type sudo whenever we want to execute a command with admin privileges. This is now necessary because we are the admin user. And we type sudo apt update and sudo apt upgrade. So apt is the package manager for Linux. And with that, we can just easily install software here on our remote machine. And with update and upgrade, we pretty much just say refresh your current indices where it looks for such software. So it will then later on also know when we try to install Java. We need to now enter the password we've previously chosen for our admin user. This is now necessary when using the sudo command, at least once every while. Hitting enter, and then you will get a lot of logs here that new software information is fetched. We need to wait until this is done, and then we need to type Y to confirm. This takes a little more. And once that is done, you will be able to enter another command again. And now we want to install Java, specifically the JDK version 21. I think our Spring Boot backend was built with the JDK 18, but we are fine using the JDK 21 in order to also run that, because the JDK 18 is not available for Ubuntu 24. So I want to say sudo apt get, that is what we can use to install a new package, apt get install, and the package is called openjdk-21-jdk. If we hit enter, yes, we want to download 675 megabytes of data, then this will be installed here on our Linux machine. And once it's done, we will be able to enter more commands again. All right, you can also now test if Java is really installed by typing java-version. And if it prints something like a specific version, then you know everything was successful with that. Okay, what comes next? Next up, I would actually already like to upload the executable jar file of our backend to this remote machine. So I could already show you that we could now run this, given that we have Java installed. So we go to IntelliJ. And how does it now work to really generate a jar executable from our code? Well, that also works via the terminal. IntelliJ has this integrated terminal. And here, there's a simple command we can use with Gradle. So simply .-Gradle W, so the Gradle wrapper. And the command is called boot jar. This will generate a jar file out of a Spring Boot project. So we execute this. Then this takes a little moment. And then, ideally, it tells you that the build was successful. And after that, we need to take a look here in this build directory, because inside the libs directory, you can now see this is where the jar file has been placed. This was just generated, and this is now a file that we can directly execute on our remote machine. We can hit right click here and actually just copy the path /reference, the absolute path, and then go back to our terminal, because now we need to exit the connection again, since we need to upload a file that is on our local machine to our remote machine. So we say exit. I'll clean this up a little bit. And now a command we can use here on macOS and Linux, on Windows that should also work if you're using the Git bash, is scp. So that is just a command to copy a file from one machine to a remote machine. So here we need to specify the source file first. So the file we're trying to copy paste here, which is the path we've just copied. And now the next argument is the remote server, so where we want to copy this file to. And since we've created this SSH alias, we can directly reference the remote server now with YouTube as well, followed by a colon, a tilde, and a slash. So this will now resolve the configuration from SSH for this YouTube alias, which will log in with the admin user using our key file, and then place this file we've specified here at the home directory of that specific admin user. If we hit enter here, then you can see it is uploading something. And once it's done, you will be able to type commands again. If we now hit or type SSH YouTube again to relog in into our server, you will see this. Now being here in our home admin directory, if we type ls, then you can see here is our just uploaded file. This is now the jar file on our remote machine that we just previously generated here on our in our local IntelliJ IDE. And now I personally want to move this file to another directory, so a common directory to place such executable server files in is the /opt directory, which is already existing on Linux. So if we type cd/opt, then you can see this is empty, but this is meant to be used for such files, for example. And in this opt directory, I will create another directory called notes for notes backend. You will see permission denied. That's exactly what we want to achieve with this admin user, because I forgot to use the sudo command. And when using the sudo command, I again need to enter my password. I think I mistyped it like this. Yeah, now it worked. So if we now hit ls here, then you can see there is this notes directory. And in this notes directory for our notes backend, I now want to move this jar file in. So what we can do is we can use the mv command in order to move a file, again with sudo mv. And the source directory is our home directory /springboot. You can hit tab to autocomplete. And then we want to move this to the nodes directory. So since we are in opt already, we can reference the nodes directory here right away. And we also need to specify the name. I will say nodes.jar. So this will take the file, rename it to nodes.jar, and then paste it into this nodes folder here. If we hit enter, there we go, that was successful. If we cd into this nodes directory now, hit ls, then there's our nodes.jar. So this was the exact same jar, just renamed. And I think the owner of this file should now also be the admin user. So if we type lsl, yes, you can see the owner is admin, so we don't need to change anything here. Except maybe that the admin is currently not able to execute this file, since the here is not an X, so reading is fine, writing is fine, executing isn't. So we can say sudo change mod to 700 for this nodes jar file. If we then type lsl again, then you can see right now we have this execute permission as well. And if we now actually say java-jar to execute a jar file with Java, and we reference our nodes.jar file, hit enter, then our Spring Boot backend will launch. And it will crash actually, because it expected certain environment variables to be there, which we currently did not specify. But you can see, this is in the end the whole idea of deploying a backend. So you take the jar file, you push it to your backend server, and then you just execute the program there. But yes, we are not yet done. We still have a little bit of work to do. As I mentioned, we do need to set up the environment file. So a file where we specify the environment variables that we want to use for this real production version of this backend now. Environment files on Linux are typically being placed in etc. So we can create a new file there, sudo nano, so our text editor again, /etc. And there is a default folder, for example, which should be there, in which we can create a nodes-env file. If we hit enter here, then a blank new file is going to be created. And here we can really just paste in our environment variables that we've also already specified in IntelliJ. So you do get these when clicking edit configurations, then clicking on this environment variables button here. If you don't see this, you do need to click on modify options, tick environment variables, click on that, and then copy over all your environment variables line by line. So let me just do this. You will see my Mongo password here, but I will change it anyways. So we don't need to blur anything. So we take the JWT secret base 64, copy this over here, then say that's equal to, and I would always make use of quotes here, so you don't have any accidental characters that would result in a line break or so. So we say quotes, and then we take our actual JWT secret, and we paste it in here, followed by a quote. Next line, we now want to paste our MongoDB connection string, paste that in here, is equal to quote, quote, and in between, we paste our entire MongoDB connection string. It's worth to say that this is not the most secure way to do this. It is a common way to store such secrets for backends, just as environment variables. But there are also ways to really encrypt these secrets, for example, and attach these to a process. This is becoming more complex. I just want to mention this, that this is definitely fine for more simple backends. But if security is really super important for you, then I would look into these ways how you can really secure these secrets and still embed them into your running instance. So once you've pasted those two lines, it will look like this. So you have the JWT secret, the MongoDB connection string, Alt-S to save this, Alt-X to exit out of this file. Now we have this file that now exists on our file system. The next thing we need to do is we need to set up a so-called systemd service. That is specifically something for Ubuntu. Because after all, you need to imagine that we are able to run our backend here with the java jar command, as you've seen, but server-side things can just go wrong. So what, for example, would happen if our backend crashes at some point? Then if we would just run it normally with this java jar command, then the moment it crashes, it will simply stop running, and then the backend will be down. It won't be live anymore. Which is why we want to create such a systemd service. That is just a kind of a service, a program whose execution is managed by the OS. And this allows us to do things like when the backend actually crashes, that it will automatically be relaunched. It allows us to do things like automatically launching this backend instance when our server relaunches, because obviously that also wouldn't automatically relaunch this if we would just use the java jar command. And with the service, we can really just declare this here as a program which has the execution managed by the OS, and it makes sure that the instance is always running and always tried to be kept alive. And these systemd service config files need to be placed in, actually we can cd into etc systemd system, hit enter. And here, if we type ls, you can already see tons of system services being set up here. For example, the SSH service. So SSH is obviously also a program which needs to have a program running in the background that is able to accept these SSH connections. And the same way, we now want to make sure that our backend also stays running in the background. And for that, we want to type sudo nano, and we are actually already in this folder where we want to create this file, and we call this notes.service, for example. And this specific config I will actually just paste in here. I think I will provide a gist or so as a link in this description, where you can also just copy paste this, but I will go over it and explain it. So obviously, unit, we have a description, our Spring Boot Notes application. After network target means that this service here should automatically launch when our server reboots after the network has been available, because our backend obviously needs network access in order to run. So we say after the network is available, we want to also run our backend in the pipeline. For the service, we want to execute this as the admin user in the admin group. We specify the environment file, which we've just created, at exactly that path. Make sure this matches the path you've created the file at. We need to specify the command that should be executed when we want to run this backend now. So here we need to specify the full path to our Java command. So just typing Java won't do it here, but you need to say, okay, this Java executable is placed in user, binaries, and then Java. We say we want to execute a jar file. The jar file is placed here in /opt notes.jar, just the same name that we've also previously chosen. It should always try to restart when something fails, specifically after 5 seconds. So this is really the main things you need to understand here. We then hit Alt-S again to save this file, Alt-X in order to go out of it. Now we want to type sudo systemctl. So systemctl, we've used that before. That is the primary command on Ubuntu in order to manage these systemd services that we've created. So in order to stop a service, in order to restart a service, in order to start it in the first place. And we want to call daemon reload. This is a command we always need to specify if the config that we've created here actually changes. And since we've created that as a blank new config, we need to call this daemon reload in order to let the systemctl command now recognize this new config file. Then we want to say sudo systemctl enable nodes.service. So the enable command is used to create a so-called symlink. And after doing this, the service will be automatically launched when the server here reboots. And then we can technically already launch this. So we can say sudo systemctl, and we want to start this nodes.service. If we do this, here it is successful, but we don't see any logs anymore. But we are able to see the logs with the journalctl command. So journalctl, for example, we want to have the last 200 logs. We say the service that we want to get the logs for is the nodes service, and we say -f, which will give us a live tail of the logs. So if we type this, you can see this already looks much better. So these are now the logs of our systemd service of our backend jar that we've deployed here. It has launched. And this time we also don't get the issue anymore that it's missing environment variables, because we've specified that environment file to be linked with this systemd service. You can see it's running on port 8085, which I've specified in the course. And technically, we can already try this out. We can try out if we can send requests to this specific backend instance that is now handled remotely on our server. Just maybe in case you are facing issues that MongoDB isn't able to connect, so you get some kind of SSL connection failure exceptions here. It could be that the issue lies in your Mongo Atlas connection settings. So here in Chrome, in our MongoDB cluster, we have this network access, which I've also explained in the crash course. So here it's important that you've specified your server's IP address now, of course, because MongoDB, the Mongo remote database, will only allow access from the IP addresses that we've specified here. So maybe you've enabled access from all IP addresses, which is the 0.0.0.0 IP address, or not, like I don't have that here. I've only specified my current local IP address, and I've specified the IP address that we now have here on our Hetzner instance, so this one. If you don't have this, then click on Add IP address. Here, you enter the IP address of your Hetzner VPS instance, and then MongoDB will accept connections that come from this IP address, because now the Hetzner service is, of course, connecting to your Mongo Atlas instance and not your local machine anymore. Once you've did that, and it looks like this, so the logs are simply blocking here and not really printing anything, so that means the server is currently listening for connections. Then we can technically just open Postman, open another tab here and try to connect. So we may just try to register an account, for example. This now works via HTTP, not HTTPS yet. I will show you in this video, of course, as well how we can set up HTTPS. And now also not localhost anymore, because this would connect to our locally hosted backend. But we now want to connect to the IP address that we've specified. So specifically, the one here from our Hetzner server. We copy this, we go to Postman, we try to connect there. And right now we also explicitly need to specify the port that we are connecting to. So our IP address, :port, and we try to register a new account. Go to body, attach JSON body. We say we have an email, test5@test.com, just something that doesn't yet exist. And we have a password that we choose, for example, test12345. If we send this, then we do get unauthorized because the route doesn't match. That is one issue, but this is a very good sign actually that we do get unauthorized. I will tell you in a moment. We need to send this to auth register. This is the route I've chosen in the course. If we send this, you can see we get okay. And if we take a look in our terminal, it's like we also get some logs here that something happened. So now we are already able to talk to our remote server, and our request here arrives at the right program, at this instance of our backend running. Of course, this is not yet secure. We are using HTTP, which means the connection is not encrypted. That means the moment we send such a password email combination, anyone who would currently intercept this network traffic would be able to see this in plain text. Not ideal. So you definitely want to use HTTPS. And normally you also want to use some sort of domain. So you don't always want to connect to this with your raw IP address, especially with a port together. So we now need a mechanism to, on the one hand, generate such a free, ideally free SSL certificate that is able to make our server accept encrypted connections. And we need a way to link our existing domain, whatever that may be, to this specific IP address and port combination. And doing so works via Nginx. So what is Nginx and why do we need this here? So normally when we actually try to connect to a certain server via HTTP or via HTTPS, then this remote server has HTTP and the HTTPS protocol running on very specific ports. HTTP, I think, on port 80 and HTTPS on port 443. That means if we try to connect to such a backend service via HTTP, then all the traffic that we send with HTTP initially goes to port 80, unless we explicitly specify that this traffic should go to another port, like here, so that our backend really receives that traffic. But when just normally accessing websites, you typically don't need to specify this port because all the traffic goes to a standard port by default, which is 80 for HTTP and 443 for HTTPS. Since we also don't always want to specify that a port here explicitly when attempting to connect to our backend, we need a way to accept all the traffic on port 80, on the standard port, and then depending on the traffic, we want to redirect that traffic to the right program. So to port 8085, for example, which our backend is running on. And this is at least one of the jobs from Nginx. So Nginx is kind of an intermediary server that we deploy, that we also call a reverse proxy in technical terms. And this intermediary server will accept all connections, will accept all traffic, and redirect it to the right program. So having an Nginx setup would also technically allow us to run multiple backend instances independently on the same server, on the same Hetzner instance. And with Nginx, we're also able to easily encrypt this traffic, so to set up HTTPS. So let's go back to our terminal. We hit Alt and C here in order to exit these logs. The service will still keep on running in the background now, but we can clean this up here a little bit with Command L. And now we need to install Nginx first. So sudo apt install Nginx, hit enter. Yes, we want to install that. Takes a little moment, and there we go. Nginx has been installed. Now, we need to configure this specific backend that we have here in Nginx, so that Nginx knows it and knows which traffic it should now redirect to which port, for example. This works with sudo nano again, since we need to create a config file again, /etc/nginx/sites available, so the available backends kind of, because Nginx speaks of sites here, so websites, but this could also just be a backend you purely use for a mobile app or so. And then in there we want to create a config file called notes. Hit enter, we create this new file, and then in here we want to create this config. Again, I will include this somewhere in this video's description as well. Specifically what this config means is we have a server, we listen on the port 80, so HTTP, not HTTPS yet. The server name now needs to be a domain. This is what Nginx will use to tell where the traffic should go to. So if we now later on access notes.plcoding.com, then Nginx will see, okay, this is the specific traffic for our nodes backend. So we want to proxy it, we want to redirect it to this specific IP address. So this IP address just is equal to localhost in this case, since localhost on our remote server references the remote server, obviously, but specifically want to redirect the traffic to the port 8085 or whatever you've chosen here in your Spring Boot application properties file for the port. And then here just some more config about, this is the actual real IP address for the server and so on. If we save this, then wrote 13 lines, we exit this out here. Then what you now, of course, need if you really want to set up an SSL certificate with a domain that you own, you of course need a domain. Technically, if you don't have a domain, you can also self-generate such an SSL certificate, which is not going to be considered secure by third parties. So that means if you, for example, want to connect to your backend via browser, then the browser will see, okay, that website has an SSL certificate, so traffic would be encrypted, but it's an untrusted one because they generated it themselves. And you will just get a big red warning in your browser if you do this, even though traffic will be encrypted itself. But if you probably want to set up SSL and HTTPS with a trusted certificate, then you do need your own domain that you own. So this is something I have to assume here at this point that you have that. And if you have a domain you own, then you also have a way to configure this domain. So in my case, I set up a subdomain, so this is notes.plcoding.com. And from the subdomain, we now need to link the subdomain to the IP address of our Hetzner server. So in Google Chrome, I've actually, this is not German, this is my personal domain hoster, all inclusive. But in the end, it will look something like this, depending on where you've deployed your domain. So you have your DNS settings. So in DNS, this is the domain name server. So when you type a domain like notes.plcoding.com, the DNS is responsible for actually checking, okay, what is the real IP address behind that? Where should the traffic go? And here we now need to say that the notes.plcoding subdomain needs to link to a specific real IP address. Of course, you're welcome to also link a real domain here without a subdomain to your backend. I won't do this since mine already links to my real website. But we can, of course, create subdomains. We can say notes.plcoding.com. For the type of the DNS record, we need to choose an A record. So wherever you have your domain settings, this is something you need to set up. And then for the data or value, we need to enter the IP address where the traffic should go to when accessing this domain. And this is, again, just our Hetzner instance. So we copy the IP address, paste this in here, and if we hit save, then it tells me that this DNS setting is already available because I've set this up previously, but in your case, this would be a new entry, of course. This is, by the way, also something we could test in Postman, that instead of talking to our IP address directly, we could say we talk to nodes.plcoding.com and we append the port here. This is still something we have to do at this point. If we fire this request, then you can see we still get a valid response code in this case. Conflict because the email exists, but the fact that we do get a response means the traffic arrives at the right program, even if we specify the subdomain. Let's go back to our terminal here on our remote machine. And we now want to cd into etc nginx /sites enabled now. Cd into that, type ls to see what is already there because Nginx already sets up a default site when accessing the server here. You'll also see this if we go to our browser and we type something like HTTP, not HTTPS, nodes.plcoding, and we type our port, then we should be able to, no, we actually don't see this yet, probably because we haven't yet run our Nginx. But let's first of all set this up and then you will see that this will work. What I actually just mean to do is I want to remove this default site. So I want to make the new site default, so the new nodes backend that we deploy here as the default for Nginx. So we want to say sudo rm to remove a file default. Hit enter and now you can see this file is gone. Next up, we want to call sudo ln to link our nodes config specified under sites available as an enabled site. So we say, hey, this is our new backend that we deployed via Nginx, and this is now something we want to use with Nginx. So we say sudo ln -s, and we specify the path to our config file, this one here, without the /, and we want to link this to our sites enabled folder. Since we are already in this folder, we can just say dot. So this references the current working folder. But if you want to be on the safe side, you should better type the full path, then you can't do anything wrong with that. So sites enabled. Hit enter here, and if we now type ls in the sites enabled folder again, then you can see now there is a notes file. So this was just created by this ln command. All right, next up, we need to type sudo apt install certbot and Python 3 certbot Nginx. Certbot is now a program that lets us create, manage, and automatically renew these SSL certificates for our backends. And this is luckily free, and it's also trusted, so you won't get these big red warnings when accessing your site via HTTPS in the browser. And for the certbot, there is just a package that works perfectly together with Nginx, so this automates all the setup. We don't need to do anything on our own here. Just describe, hey, this is the server we have, here's the Nginx files, and so on. Hitting enter here, we install these packages, we type yes, hit enter again, and then we can now generate this SSL certificate by saying, let me actually clean this up here, by saying sudo. We want to use the certbot with the --Nginx keyword, since we want to generate an SSL certificate for an Nginx file, and then certbot will automatically configure our Nginx configuration files so that it accepts HTTPS traffic, and then to specify the domain or subdomain for this certificate, for which this certificate should be issued, we want to say notes.pl-coding.com, or your subdomain or domain, of course. And at this point, you need to be sure that you've really linked the subdomain with your server's IP address as well, because certbot will do certain verifications in the background. And if something doesn't match, it will tell you, and issuing the certificate won't work. So make sure you've changed the DNS settings before, and you've also verified that the domain you're linking here already points to the IP address of this server here, because depending on your DNS provider or your domain provider, this can sometimes take, they always say up to 24 hours or so, but usually it's done in a few seconds or minutes. So if we type this sudo certbot Nginx, create this here for our subdomain, we do need to enter an email address. This is for urgent renewal and security notices. So you type your email address here, hit enter, then yes, we want to accept the terms and conditions. Yes, we are willing, and then it's actually requesting a certificate. This takes a little moment, and then it tells us it is deploying the certificate, and it successfully deployed this for this particular subdomain. And we have successfully enabled HTTPS for this URL, and you can see now we should be able to connect to it via HTTPS without specifying the port, by the way. So if we now say sudo systemctl, since Nginx is also a systemd service that always runs in the background, of course, to listen to requests, and want to reload the service, so reload Nginx, then if everything was successful, we should now be able to directly make these requests here to our subdomain via HTTPS, now encrypted, without specifying this port. So we do this, we click send, and we do get conflict again. That means the request is going through, it's not complaining about any HTTPS configuration issue, we did not specify the port, and we do get a valid response. It's a conflict response, but we do get a response that comes directly from our backend. Otherwise, you would definitely see a different error here. Awesome, I'm really happy this now works, because this means regarding the server setup, we're done. The last thing that now remains, as promised, is that we make this whole process just more convenient. Because if we think about it right now, whenever we are in IntelliJ and we make a certain change to our code, we add a new feature, we fix a bug, whatever, then in order to get this new change and deploy it to our VPS instance, what we would need to do is, we first of all need to build a new jar file in IntelliJ with the boot jar command. We need to take this jar file, copy it over to the remote server via the scp command, then log into the remote server, make sure to copy this jar file into the right folder that it's referenced by our systemd service, restart the systemd service, and so on. Good news is we can automate all of that. And in the real world, this happens very often via a CI/CD pipeline, specifically CD, which stands for continuous deployment, where these automation steps that are directly linked to changes in our source code, that these are directly linked to, in our case, GitHub, so to where we have our Git repository. And specifically in this case, we will use GitHub Actions, since it's free and integrates directly with GitHub. So what we will implement is this entire workflow, step by step, what needs to be done, which commands need to be executed on the remote machine in order to generate a jar file, push it to the remote server, rerun the server there, and so on, whenever we push to the master branch. Depending on what kind of a project you are, of course, working on, this specific config may, of course, differ a little bit. So if you're just having a single master branch, then it's, of course, also quite dangerous that a single push will automatically deploy these changes to production. So in the real world, it's common that you only push these deployments when a pull request is successfully merged or so. It's very often the case that the master branch is restricted, so you can't push to it directly, but only via merged pull requests where there must be, I don't know, at least 2 reviewers who have approved it. So these security measures you can apply at the GitHub level itself. In this case, I will show you how this works with pushes directly to master, which I think will also include merged pull requests, because a merged pull request into the master branch is also automatically a push to master. In this GitHub Actions file, so we do need to specify this workflows file that outlines these commands we need to execute in the right order. This is something I will also paste here, but explain every single line, since I don't really see a reason in typing this off. It's a YAML file, so this is just the way how GitHub Actions works, but it will make sense when we create this. So in our root package here, we want to create a new directory. We call .github/workflows, so that we have this folder directory. This naming is very important here, because whenever we push code to GitHub, it will look if there is this directory, if there is a workflows directory, and then it will take a look at all the YAML files inside this workflows directory to see if there are any automations it should execute. Just adding this directory will automatically allow you to use GitHub Actions. And in this workflows folder, we will create a new file, deploy.yaml, so YML. This is our deployment workflow. And yes, I want to push this to GitHub, otherwise GitHub won't know it. So in this deploy YAML file, I will now paste the entire configuration here that we need in order to deploy this and automate this whole thing. And I will now lead you through every single bit. Because from this point on, you can really just always copy paste this file to your other backends that are jar-based. So where you generate a jar executable like Ktor, like Spring Boot with Java as well, by the way. Because in the end, executing a jar file will always stay the same on the remote side. We don't really care how this jar file was built and whether we used Kotlin or Java under the hood. So we first of all specify the name of this entire automation, which is we want to deploy the nodes backend. Then GitHub Actions wants us to specify certain triggers. So when, under which scenarios it should actually execute this entire pipeline. So on pushes to the branches that we specify here, and in our case specifically just master. Make sure you of course have this master branch and it's not called main for you or so. In that case, you would need to swap this out. And then we can specify one or multiple jobs here that are part of this deployment pipeline. In our case, we just have one job, which sequentially executes certain steps. This is called deploy, and it runs on an Ubuntu server. So these steps that we now declare here, how the job should achieve this deployment, these will be executed on Ubuntu as well on GitHub servers. And now we really just outline step by step what GitHub, what this Ubuntu instance should do in order to push our new jar file to our remote server. First of all, it needs to check out our repository, so it really has this code so that it can have something as the foundation to push it to the remote server. Next up, it needs to set up SSH. So there's just this tool here from GitHub, which we can use to set up SSH, so we can connect to our own Hetzner instance from this GitHub Ubuntu instance via SSH. And here's now important, we of course need to authenticate in some way from this GitHub Actions Ubuntu instance to our own instance. And that is again where this private key file of our SSH setup comes into play. Since we don't want to include this private key file here in plain text in our deploy YAML file, which will be pushed and must be pushed to GitHub, we need to rely on GitHub secrets. So in GitHub, we need to paste our private key file in a moment here, so GitHub can reference it during this pipeline. This is also why it's important that we previously did not set a password for this private key, where we were prompted with this, because every single piece of command that comes with that prompts us for certain user input, like here you enter a password, here accept with yes or no. This is not possible in the GitHub Actions pipeline. Since we don't control this, it should be fully automated, and it can't automate these kinds of user inputs. So that is why it's important to reference a key that does not, where we're not prompted with a password, but it will directly proceed with this key and connect to our backend. Next, I want to add this server, so our own Hetzner backend, to the known hosts file. This is also for the same reason. This known hosts file just includes all the SSH hosts that are currently known. If the host we're trying to connect to is not known, which will always be the case here, then it will complain, and just like on our own terminal, it will ask us, hey, do you want to add this key to the known hosts file? Which again is a piece of user input, which would break our pipeline unless we previously specify that this is part of our known hosts. And this Ubuntu instance is, by the way, always a completely fresh new instance that executes these steps. So we can't really reference any files we create here in the next run. So we always need to come with the entire setup that would deploy this backend here on a fresh new Ubuntu instance. Next up, we want to build a jar file. And specifically, we want to run the Gradle w boot jar command. Just like we did here in our IntelliJ, we want to now take this code we've previously checked out here in GitHub Actions, and we want to generate a jar file from that. And then finally, the biggest step here is really deploying this jar file to our server. So here, with this pipe, we can really achieve that we can enter multiple shell commands that we now want to execute on this GitHub Actions Ubuntu machine. And the only thing we need to swap out here, since I've copied this over from my prepared project, is we of course need to reference the jar name. That is the default name created when running the boot jar command. And for that, we really just need to take a look here on the left side, right click and call rename, just so that we can copy over this entire jar command. I'm not meaning to really rename this. And then pasting this in for the jar name or whatever project you have, or however you named your project. This also needs to be treated a little bit with care, since if you at some point bump your version of the backend, then the jar naming would also change. So in that case, you could also dynamically retrieve the current version here and then add this as a placeholder here. So this would generally work for any type of version. Cool, so we have the jar name. We specify the local jar path. So here in our project hierarchy, which is under build libs jar name, which is exactly the path right here. We specify the remote server. So when I log in as the admin user, add our IP address. We specify the remote jar directory, which is not notes prep in my case, but just notes. So that is the directory under the opt directory that we've specified, where we really want to paste this jar file here that we are uploading. And then with the rsync command, which is similar to the scp command, we can really connect to this remote server here and copy over a file. So we can copy over this jar file we have kind of locally at the remote machine from GitHub Actions, and we want to upload this to our own server, so the new jar file. And this works via rsync. So we say, hey, here's our local jar path, our local jar file, and we're gonna push this to our remote server. With a colon, we can then specify a specific directory we want to push this to on a remote server, which is the remote jar directory. So our opt notes directory / and our jar name. And then with this block of code, we can just execute certain commands directly on our remote server. So we connect to it. We connect to the remote server right away. For that, the private key file will be used that we specified here previously via this SSH agent. And then we first of all use the mv command, so moving a file, but that's also used to just rename a file on Linux. So and to really just use this to rename the jar file here with this long name that was generated from Gradle to the short notes jar, just like we called this in our systemd service configuration on the Linux side on our own Hetzner instance. So this renames this. And then lastly, we call sudo systemctl restart. So we restart our systemd service, and that will now reference the new nodes jar file we've just pushed to the backend. Now, in order to make this work, there are a few last little adjustments to be made. One of them is on our Hetzner instance. So here, we want to type sudo vsudo because, as you already guessed, and you can also see this here, the moment we type sudo, which is required for our admin user, we are prompted with a password. In GitHub Actions, we can't really respond to that prompt, and still we need the sudo command here in order to restart our node service. With sudo vsudo, we can define rules and we can exclude certain commands from prompting us with a password when being executed as the admin user. So I will enter my password here, and then we get to this config file, this sudo ers file, in which we can define these rules. And specifically, we want to scroll down here, and we want to add a line at the very bottom where we say admin, all equals all in parentheses. And after that, we say no password, so no passwd, and we specify /user/binary/ /systemctl restart notes.service. What this line means is that this command here, so systemctl restart, again having to specify the entire path to that systemctl executable, this command should not require a password. We still need to execute it with sudo, but if we call sudo with that command, then it won't prompt us for a password. And we only want this for this single command, since we need to execute this as part of our GitHub Actions pipeline here. So the moment we call this here from the GitHub Actions instance, this won't come with a password prompt, and it will just proceed with restarting the servers. So here we can hit Alt-S again, Alt-X to exit out of that. And that should already do it in order to let the GitHub Actions pipeline execute this step. Next up, we of course need to add this deploy key here, so our SSH private key to GitHub, so the GitHub Actions step can properly read this from our secrets. We can do this in Chrome here. I've already opened the GitHub repository, and here under settings, we can go to secrets and variables, and for GitHub action related secrets, we can click on actions here, and then we want to create a new repository secret. Make sure you call this deploy_key, so exactly the same as you've specified in here in your GitHub Actions file. And then for the actual secret, that is something I won't show you here, but you actually need to open your private key file now, not the public key, since we need this in our GitHub Actions pipeline to connect to our Hetzner servers. You open this notes file without .pub, so the raw notes file, and copy all of its content in here. That is what I will do off screen. And after hitting save, it will look something like this, where you have your secret saved here called deploy key. And then after we've added the secret, I'm not entirely sure if we do need to explicitly enable actions. This has happened to me before, but the what comes here looks a bit differently to what I expected. So maybe this will look differently when we actually push our code with the GitHub Actions file. But we could also create the file directly here, but we've already written this here in our IDE. So the last thing we now really need to test is that we make a little change to our code and then push this to the master branch on GitHub and see if it really deploys to our server. This is now the final thing for this video. So let's just come up with something like a hello world controller, or just let's call it a status controller. So this is something you commonly have on backends, that you just have a status route you can call to see if the backend is currently live. We annotate this with REST controller. We say request mapping, and we say, okay, we just use the request or reference the request that come directly to the base route. And then we say we have a get mapping function, get status, and this will respond a string. And we can just say everything cool, something like this. Because if we are able to see this string, then we know that the server must be live. Then we also need to go to our security setup here, so the security config, and explicitly enable access to this route without requiring authentication. So we can specify a request matcher to this base route and then say permit all. So permit all requests without authentication. And then I would say we can make a commit here, set up a GitHub Actions, commit this, push this to our master branch, and then we should be able to, I don't know if we do need to, okay, it is already enabled. I think for public repositories, it's enabled by default. For private ones, you need to do this manually. Here you can now see our workflow is running. And if we click on this and on deploy, we can see what it's currently doing and which steps have succeeded. And if some steps failed, why they failed. So here you can see currently building the jar file. This, of course, takes a little moment here, since it always needs to rebuild the jar from a completely fresh build setup, since it always freshly checks out your code. So there are no build caches that we can really make use of here, at least if we just build this once and not multiple times in the same workflow. All right, that build was successful. Now it's deploying this to the server, and that failed. Okay, interesting. But now you can already see how we can attempt fixing that. So it said permission denied when trying to rsync this. So when trying to upload this jar file to our server. Let's take a look in the GitHub Actions file if there is a specific issue. Specifically here at this step, it actually failed. So my feeling is that it's not properly recognizing this private key we've specified here before. Because if that was successfully specified, we would be able to rsync that to our server. So it says permission denied for this command when connecting to our server, which means that is something that I can't spontaneously tell you, and I need to look into that. And then you will see the moment why we have an issue here. All right, I think I figured it out. Just to also give you some context on how, first of all, in GitHub Actions, you can rerun these jobs. You can say rerun failed jobs, and then there is a tick to enable debug logging. This can sometimes help, didn't help in this case, but you could see then you get more logs in each step in order to just maybe find out what the reason could be. In this case, we still see permission denied. But the way I went over this in order to debug this is I tried to use the rsync command on my local machine in order to copy a file to this backend. And I came to the conclusion that I could perfectly push a file via rsync to the admin's home directory, but not to our opt directory. So this one here. And that implies that there's nothing wrong with the SSH key that I've entered here as a GitHub secret, but more that this directory doesn't really seem to belong to the admin, but rather another user, and the admin does not have privileges to write to this directory. And we can also check this, and I did, and I confirmed this. So here I am logged in on my Hetzner instance, and if we navigate to opt nodes and we type LSL again, then you can see that the nodes jar file belongs to our admin user. But if we type lsld, then we see all directories. So the dot directory is the current directory, this nodes one, and that belongs to root. And if this belongs to root, then the admin user can't write to it. That seems to be the issue. Haven't tried it out after making this change, but we can change the owner here as well of that directory to admin and the admin group. Also, I think with the r dash before, which isn't needed in this case, but it would apply this recursively to all nested directories. So I typically use this to be on the safe side. And then we simply type a dot to reference the current directory. If we do this, then operation not permitted because I didn't type sudo. So let's do this, type our password, and then that seems to be successful. If we now type lsld, this directory now belongs to the admin user. So we can go ahead in Discord Actions, rerun the failed jobs or rerun all jobs. That's the same. Click rerun jobs and hope for the best. So this takes a little moment until it restarts this. We click on there, and then we should be able to see the same steps executing in a moment. So the first steps always pass quite fast, and then it builds the jar. And let's wait a moment and hope that this now works. So there we go, our build is successful. And now the difficult part starts, deploying the jar to the server. And that seems good. We get the check mark. That was successful. And the entire deploy step now has this check mark. Now, let's try this out, because if this deployment was successful, then that means that in Postman, we are able to call the base route, and we should get back our, I think, cool everything works string back. We call this, and there it is. It works. I still want to share one last optional thing for you that I still recommend you to apply. That is that right now we did not yet set up and configure a firewall for our server. So with a firewall that we can and should set up, we can block access and we can block traffic coming to specific ports directly. And right now by default, all ports on our Hetzner server would technically be open. And there are just certain programs, for example, Nmap, that is a popular one, that allows you to scan all the open ports from a remote server. And this can give an attacker a lot of hints on which programs are actually running on this remote server. To possibly, for example, think about which of these programs, which of these ports may have some kind of security vulnerability or so in order to get access to your server. That's something we want to prevent. So we want to say the only ports that we allow access to on our remote machine is HTTP, HTTPS, and SSH, so we can still connect to that server. So as you can see, it still works even if we don't do this. Still, I want to show you how we can really secure our backend. So here I am again on our console, and we want to type sudo apt get install ufw. That is the tool that it makes it very easy on Linux in order to configure the firewall and which ports you want to allow access to. So we hit enter here, type our admin password, and then, okay, in this case, you can see this is already installed. Depending on where you have hosted your server, this might not be the case, and then something would be installed here. We should then also be able to type ufw version to see which version is installed. And if it prints something like this for you, then you have it installed. Cool. Next up, we want to set the default policy. So by default, we want to allow all outgoing traffic, so where our server sends traffic, sends data somewhere else, but deny all incoming traffic, so where clients just try to connect and communicate with our server. And that works with sudo ufw default. And by default, we want to deny the incoming traffic. You can see this is now denied. Then we want to say sudo ufw default allow outgoing. So we allow all the outgoing traffic by default. And now we just want to add fine-grained rules just for those 3 ports that we still want to keep access to, or we still want to be able to connect to from a client device. So we can say sudo ufw allow port 80 slash TCP. So TCP is the protocol. This would be the port HTTP, so that we can accept HTTP non-encrypted traffic. Then we want to do the same for 443 for the HTTPS port, so that our backend can properly receive traffic from clients. And lastly, you want to do this for port 22, which is the port where the SSH tool actually listens for incoming SSH connections. Since we still want to be able to connect to our server, that is also a rule we should add here. And then we need to simply enable UFW, so sudo UFW enable, hit enter. This may, of course, interrupt our existing SSH connection, depending on the rule. Since we've allowed traffic to SSH, this did not happen here, as you can see, but it now tells us the firewall is active and enabled on system startup. And in case you want to check all of your rules, you can also do this with sudo ufw status numbered. So then you get this list here of all those rules you've specified with this firewall tool. And then if we now go to Postman, we should, of course, still be able to connect to our backend and make a request to. So if we hit send, we should see the exact same value here. Everything is cool. Yes, that is the same. And now with this setup, I know it was a lot of work, but the thing is, you need to do this setup just once. Just once when creating this VPS instance. From now on, everything will be automated. Every single change you make in IntelliJ, you just push to master. It takes 3-4 minutes and it's live. The server is set up in a way that it's on the one hand secure via this admin user, so not too insecure at least, that we can log in as root. The backend that we have here will automatically be relaunched when the server, the Hetzner instance, relaunches. We have our domain, we have set up HTTPS, which the cert bot, by the way, will also automatically renew. So SSL certificates expire after some time, I think 90 days or so. But the cert bot will automatically renew that certificate for you. So you won't even notice anything from that, and it will just work. And this is what I mean. Yes, you can directly deploy your instance to something like AWS. You just drop in your jar file and it's suddenly live. That works. Setting that up with HTTPS and a domain is still a little bit extra work, but in total, it's easier to deploy a backend on such a cloud provider because that's their business, to make things easier for you and to connect different parts of backend technologies. But if you just take the time once, you understand this whole workflow, you understand how Linux machines work, how you can connect to these just once, you set up everything like I showed you here, then for the rest of your life, you will be able to go with these custom backends. They will save you so much money because you don't need to send all your money to big tech companies like Amazon, which will definitely charge at least 10x the amount of what such a Hetzner instance costs you here for the same things. Yes, you can still add such cloud providers, such cloud services as add-ons for certain things. As I mentioned, if I would need some image storage, yes, I would use something like Amazon S3. If I would rely on a remote database, I would probably also go for something like Mongo Atlas. Technically, you could also host that MongoDB instance on your Linux machine. So you would install the MongoDB package. You would just set up a local MongoDB instance on that remote server. Would also work. But the more things you, of course, add on this Hetzner instance, the more things you also need to fix when they go wrong. You need to care about then backing up your database. You need to properly secure it on your own. You need to configure the network configuration of that database. And if things go wrong, you just have to fix it. That is the downside of having your own managed server, which is why I kind of take a hybrid approach of outsourcing the stuff that is very sensitive, like the images, the database, to cloud providers, because these parts are usually not the most expensive ones, and then leave things like load balancing, leave things like hosting the instance itself on such a VPS server or on your own dedicated instance. I know it was a long video. Thanks so much for watching this far. I really hope you enjoyed this, you learned something. Definitely let me know if you enjoy these backend videos, because if you do, then I'm of course very, very likely to make more of them. Thanks so much. Have an amazing rest of your week. See you back in the next video. Bye bye.